So we're now
just over 1,000 RPM. 2,400.
Yeah, it's pretty promising.
Yeah. Would the amount of cavitation be affected by like our particular blade geometry?
Yeah.
As well?
I remember Zach organizing this workshop out in California. It was about reusable rocket engines, and there was this huge outcry from industry about students not having enough hands-on experience. Not just hands-on, but not knowing how to make things. So when they design, keep that in mind.
Yeah, I think it's making things, but using modern manufacturing tools. So things like 3D printing, metal 3D printing, plastic 3D printing, rapid prototyping for engineered devices.
We can use Bernoulli's principle.
We're spending this semester pretty much designing and then building this pump system.
The overall idea of like turbopumps is that they're used in a lot of similar machines. So on a bigger scale, you could think about using them like a jet engine or a rocket.
It works. And if you operate at maximum speed, it doesn't leak.
It's nice to have a system that you can take responsibility of the whole thing and then figure out all the little details that end up to what puts, people on the moon.
We started off by designing basically some impellers.
impellers that are 3D printed metal. Starting to get to aero.
We didn't specify the specific pump designs, the impeller shapes, really anything. We gave them tools. They developed their own designs, and each team arrived at their own unique, specialized design. And many discovered interesting design features which are actually used in like
Real applications.
Yeah, the real high-performance engines.
That works.
Yeah, you're moving stuff.
So far, it has gone remarkably smooth, in large part because we have exceptional students, and then also exceptional TAs.
The TAs play a huge role.
Yes.
So with that, it should be dry. Because it's a new course, we're running it for the first time. We spent most of the summer developing the lab activities and the problem sets that would go with it, and then most of the fall course correcting as fast as we could and just reacting to how the students were learning.
Yeah, we start every module with familiarizing the students with the same concepts, but after that they all branch off into their own designs basically.
This class is probably the most multifaceted class I've ever taken. I think it really captures the entire process of an engineering cycle.
Some of the parts that they're using were farmed out to manufacturing companies.
Yeah, especially with 3D printing, like essentially we have, 12 teams? And so if we're trying to print 12 of these, it would have taken like months.
Different teams use different manufacturing techniques and different materials. Different color, different surface finish, different mechanical properties, and maybe different performance. And they're gonna see.
I think initially we chose polycarbonate because it was the cheapest option, but it would have absorbed a lot of the water that we were going to be using. So we decided on nylon 12 because it was the second cheapest option.
They're using actually the auto pricing tools to assess cost curves, and they're actually seeing how that directly relates to fundamental things that they learn in lecture.
And how to deal with vendors, right? If you don't communicate well, you won't get what you asked for, right?
Yes.
Oh, the seal's leaking.
Oh, this is a problem. No. Drainage system?
Do you guys have a drainage system?
Okay. All right.
Well, anyway, we got our data.
How much oil?
Being able to use all of the design principles and things we've learned the past 4 years to be able to incorporate all of these into one system that's integrated has been really nice.
You're doing a problem set, you're just working through numbers, and then you look back and there's plenty of time to revise it. But once you're doing these more hands-on and practical applications, the decisions carry a lot more weight, and so at some point we just had to decide that this impeller design is what we want to go with, and we're going to actually go get it printed. Same thing for our rotordynamic setup as well as like the casings. So I think that process of learning with your team when to kind of commit to a decision and what variables you need to know to feel confident in that, I think that was pretty unique from past classes.
Really stepped up becoming engineers.
It's also a communications intensive class. So the main deliverables aren't exams or anything like that, but it's a presentation and a report. And so that kind of communication stuff, we like having input from the communications department.
To be able to use the process of communicating to somebody else to really enrich and deepen your own understanding.
These students, they might develop more efficient aero engines. They might develop better, more reliable rocket engines. They may develop the next consumer electronic device. The skills that they're learning here are transferable to like any kind of physical system.
Water pressure.
Like these students are now going to go off and they're going to have huge impact. And I'm excited to see how they apply what we teach them in the real world. and what implications this has for our partners in industry, for the next generation of technologies. These are the future leaders, and it's our privilege to get to educate them.